let's say I want to think about this function f of alpha is sine of alpha, where alpha is measured in degrees. And I wonder what's the first derivative and what's the second derivative. All right, so it's not as easy as it looks because it's not cosine of alpha, because we know that f of x, if f of x is sine x and x is in radians, the derivative is cosine of x. But this angle alpha is measured in degrees. And so I need to think of what's the relationship between degrees and radians. I know if I have an angle in degrees, I can multiply it by pi and divide it by 180, and that will give me the number of radians. I'll call it x, which is a function of alpha, because there are pi radians in 180 degrees. And so if I'm looking for the change in f with respect to alpha for the first derivative, that's really the change in f with respect to x times the change in x with respect to alpha. Or I'm thinking of using my inside function as this 180, pi over 180 times alpha. So that gives me the change in f with respect to x would be cosine of x times this derivative of pi over 180 times alpha with respect to alpha, which would just be pi over 180. And now I need to get it back in terms of alpha, and so I get cosine instead of x, pi over 180 alpha times pi over 180. It's a little more complicated than just cosine of x. Okay, that's the first derivative. I guess I could rewrite that as, I could put the pi over 180 in front if I wanted to. That's the first derivative. That's f prime of alpha. The second derivative, I need to take the derivative of the first derivative. And the first derivative was here, pi over 180 cosine pi over 180 times alpha. And so I need to do the chain rule again. Maybe I'll say the inside function is pi over 180 times alpha, and the outside function is pi over 180 cosine of x. So my derivatives, if those are my functions, my derivatives would be pi over 180 times negative sine, so I make that negative. And the derivative of the inside function is just pi over 180. And so for my second derivative, f double prime of alpha, I get negative pi over 180 sine of x times pi over 180. And then to get this back in terms of alpha, we get negative pi squared over 180 squared sine of pi over 180 alpha. So that's how we can do that. And that's why we use radians instead of degrees, because in degrees with these trig functions, the derivatives are much more complicated. Let's look at the next example that I've got. Where we just use the chain rule a whole lot. 1 plus parentheses 2 plus 3x to the fourth, that's to the fifth, and then the whole thing to the sixth. Okay, so we have to do like a lot of chain rule stuff. So I might say to start off with that my outside function is u to the sixth, and if that's my outside function, my inside function, or u, is 1 plus parentheses 2 plus 3x to the fourth to the fifth. So if that's my function, then for my derivative, this would be 6u to the fifth. And to find the derivative of the inside function, I actually have to use the chain rule again. Let me change my pen color here to try to keep track of stuff. And so for this one now, my outside might be 1 plus w to the fifth, and so my inside would be 2 plus 3x to the fourth, where I'm calling that w. That's the function there. And so the derivative would be 5w to the fourth, and the derivative of the inside function would be 12x to the third. And so the derivative altogether would be 5w to the fourth times 12x to the third, or instead of w, that's really 5 times 2 plus 3x to the fourth times 12x cubed, or 60x cubed, 2 plus 3x to the fourth. That's what I put here. 60x cubed, 2 plus 3x to the fourth. Now I can answer the real question about g prime of x and say it's 6u to the fifth times 60x cubed, 2 plus 3x to the fourth, or 6 times, let's see, u was 1 plus 2 plus 3x to the fourth to the fifth times 60x cubed times 2 plus 3x to the fourth. This is making me a little bit nauseous. The last thing I could do to clean this up might be multiply the 6 times the 60 and get 360x cubed, 1 plus 2 plus 3x to the fourth to the fifth times 2 plus 3x to the fourth. Please stop here. Yikes. Wow. That's how this works. That's how we would solve that problem. We would find the derivative. That is the first derivative of that function. We had to use the chain rule a couple of times. Don't be surprised when you get asked to do that. Next, I'd like to look at a couple of other functions. Capital F of x is 3 minus sine of x to the 3/5 power. So my inside function, or u, would be 3 minus sine x, and my outside function would be u to the 3/5 power. So derivatives, using the power rule, we can do this with rational number powers. It would be 3/5 times u to the 3/5 minus 1. That would give me negative 2/5. If that doesn't make sense, go ahead and think about 3/5 minus 1 is 3/5 minus 5/5, and that's where I get negative 2/5 from. The derivative of 3 minus sine x would be 0 minus cosine x, or just negative cosine x. So the derivative of f would be 3/5 u to the negative 2/5 times negative cosine x, or negative from the negative cosine, 3/5, and instead of u, 3 minus sine x to the negative 2/5 power times cosine of x. Please leave it there.